Have, have you ever wondered what the temperature is in outer space? Well, no matter how you express it, it is very cold, even close to the sun. We can explain this phenomenon in terms of energy, which is the ability to do work, and matter, which is anything that has mass and takes up space. Energy does work when it forces something to move. As the particles move faster, the temperature increases. Well, if there's nothing there to move, no work can be done even if energy is available. You see, outer space is void of matter. Therefore, the energy from the sun doesn't have anything to warm up. We feel the warmth of the sun as the sun's energy forces our body's molecules to move faster. In other words, work harder. Let's explore this concept in more detail. The energy from the sun is called radiant energy, or energy possessed by vibrating particles. Vibrating particles in the sun create waves that travel through space and time. We call these waves created by vibrating particles electromagnetic waves. Electromagnetic waves contain both electrical and magnetic properties that allow them to travel through space, even though space is void of matter. Other waves, for example, the waves of the ocean, require matter to move. We can easily demonstrate the formation of waves from vibrating particles. Here, let's do a little experiment. If you got a cup of coffee, assuming it's cool enough, or a glass of water by you, just stick your finger down in the water and wiggle it, vibrate it back and forth, and watch the waves form. Now, while these are not electromagnetic waves, the concept is similar to how vibration forms. As we just discussed, electromagnetic waves can travel through outer space. They can travel for long distances, and they move at the speed of light. Work is done by radiant energy as the electromagnetic waves come into contact with particles and cause them to move. Let's examine the sun as a source of radiant energy. Radiant energy from the sun is specifically referred to as solar energy. The sun contains a tremendous amount of radiant energy that produces electromagnetic waves. These waves travel away from the sun through space and time. When the waves come into contact with some object, well, let's say our skin, they cause the molecules in our skin to move faster. As the molecules move faster, we feel warmer. Those same electromagnetic waves traveling through space don't do any work because there isn't anything to contact. At the same time, there is nothing to stop the waves, so they continue to travel until they hit something. To better understand how radiant energy works, we need to look at electromagnetic waves in a bit more detail. Electromagnetic waves are similar to other waves, like waves in the ocean, in that they have high parts and they have low parts, and they move. The tops of the waves are called crests, and the bottom of the waves are called troughs. Just as there are different kinds of waves, there are different types of electromagnetic waves. And each type of electromagnetic wave is defined by its wavelength. Well, what's that? It's simply the distance between the waves. While it is easier to measure the wavelength of waves in the ocean because we can see them, scientists have come up with ways to measure the wavelength of electromagnetic waves even though we can't see them. Another way of looking at the different types of waves is by their frequency, which can be thought of as the speed at which the wave moves. Frequency can also be expressed in terms of hertz, or the number of waves formed in a period of time. Waves with long wavelengths have shorter frequencies, while waves with shorter wavelengths have higher frequencies. Okay, so what do these waves have to do with energy? Let me start off by saying that electromagnetic waves carry energy. Electromagnetic waves with the shorter wavelengths and higher frequencies carry more energy. In other words, they have a greater ability to do work. Let's think of it this way. Consider someone punching a bag. Imagine each punch being equivalent to a single wave. If that person punches faster, the bag will move more. In other words, more work will be done. Likewise, a wave with a higher frequency would possess a greater ability to do work, which, as you know, is energy. Now that we understand the nature of radiant energy and electromagnetic waves, let's explore different kinds of radiant energy and what each type does in nature. What you see on the screen is a spectrum of all the electromagnetic waves that we know of. On one end of the spectrum, we have high-energy waves. Gamma rays and X-rays carry a lot of radiant energy as they have high frequencies and short wavelengths. We're familiar with X-rays as they're used to make pictures of our bones. The other end of the spectrum is composed of waves with low energy. These waves are low in energy as they have lower frequencies and longer wavelengths. Radio waves carry audio signals from the radio station to the radios in our cars and homes. The electromagnetic waves in the middle of the spectrum are ultraviolet light, visible light, infrared radiation, and microwaves. Even visible light has different wavelengths, which accounts for the different colors that we see. Let's summarize what we've learned in this lesson. Radiant energy is energy possessed by vibrating particles. Radiant energy is one of many types of energy where energy is the ability to do work. Radiant energy is transferred in the form of electromagnetic waves, or waves composed of electrical and magnetic properties. Different electromagnetic waves can be identified by their wavelength, or the distance between the waves, and their frequency, or the number of waves formed in a period of time. Electromagnetic waves with high frequencies and short wavelengths are high-energy waves, while those with low frequencies and long wavelengths are low-energy waves.